Suppose A and B are two sets such that A intersection X equals B intersection X, and both of these two sets are null sets, and A union X equals B union X for some set X. Then show that the two sets A and B are equal to each other. Let us begin. So here we will start with the given condition that A union X equals to B union X for some set X, for some X. Now what we'll do, we're going to take the intersection of each of the two sets with A. So that means we have A intersection with A union X equals to A intersection with B union X. Now whenever we have a set A intersection with A union X, this is simply going to be the set A itself. That's by definition. So let's write it out. Since A intersection with A union X is simply going to give us the set A itself. So this will be equals to A intersection B union X, but what we'll do, we'll distribute A with B union X to get A intersection B. So this is going to be one set and union with A intersection X. Fine. So that gives us A equals to A intersection with B union. Now A intersection X, that's already given to us that it's the null set, so we replace it with the null set. Since A intersection X, that's equals to the null set. So here we have the set A equals to, now we know that any set when we take its union with the null set gives us the set itself. So that means this will be simply A intersection B. So here we have used the fact that A intersection B, when we take its union with the null set, that's simply going to give us the set A intersection B itself. So that means here we have A equals to A intersection B. So this simply tells us that A is going to be a subset of the set B. Okay, so this is one condition that we have obtained. That means if we start with A union X equals to B union X, here we can say that A is going to be a subset of the set B. Okay, then again we're going to use the same condition, A union X equals B union X. Again, we have A union X equals to B union X. This time what we'll do, we're going to take the set B and take its intersection with each of the two sets on both sides. Where B intersection A union X equals to B intersection B union X. Now using the same definition, this time B intersection with A union X, so what we'll do, we'll distribute it. So we have B intersection A union with B intersection X. This will be equals to, now B intersection B union X, that's simply going to be B. So here we use the fact that B intersection B union X, that simply equals to the set B. Now we have B intersection A, but we can rewrite it as A intersection B union B intersection A. That's already given to us that that's the null set. So here we can replace B intersection X with the null set. So that will be equals to B. So we have used the fact that B intersection X, that's equals to the null set. Okay. Now, what is the union of a set with the null set? Again, we have the same set. So we have A intersection B, that will be equals to B. So here we have used the fact that A intersection B, this is the set, and when we take its union with the null set, we get back the original set A intersection B. Now we can rewrite it as B equals to A intersection B. So this simply tells us that B is going to be a subset of the set A. Fine. Now this is condition number 2. So in condition number 1, we obtained that A is a subset of B, and in condition number 2, we have B being a subset of A. So when we combine both the two conditions, so from 1 and 2, so we are going to get A being equal to the set B. So here we have used the definition. So let's say for two sets, let's consider them to be X and Y. So if X is a subset of the set Y and Y is a subset of the set X, then it follows that X and Y are two equal sets. So that's what we have shown here, and this proves the problem.